Now let's talk about multi-step equations. So with multi-step equations, you want to have variables on one side and then numbers on the other side. Remember, the thing with equations is that you can add or subtract anything from one side of the equation as long as you do the same thing to another. So let's look at an example. Remember, the whole goal here is to isolate x, is to get x by itself. Start with terms that are the furthest away from x. So what I mean by that is here's negative 7, which is over here being subtracted. You can get rid of this negative 7 by adding 7 to both sides of the equation. So now it's gone. So now you're left with 5x is equal to 25. The next step is to get rid of anything that's closest to x. So notice the 5 is being multiplied by x. So our next step would be to divide by 5. And so then we would get x is equal to 5. Remember, you can always plug answers back into the equation. You'll see me stop doing that in a minute just for the sake of time in this video. But when you plug 5 back in, you do 5 times 5 minus 7. Does that equal to 18? Well, 25 minus 7 does equal 18, so we know our answer checks out. So again, you can always plug answers back in. Again, I'm going to start with whatever's furthest away from x, so in this case, the negative 8. So I'm going to add 8 to both sides to get rid of it. So I get negative 42 is equal to 7x. So I know now what I need to do is get rid of the 7. So what I'm going to do is negative 42 divided by 7. And so then I get x is equal to negative 6. Circle my answer over here too. Now, this one's a little bit different because you're like, well, there's x's on both sides. Remember what I just said on the last slide. You want to get all your x's on the same side and all your numbers on the same side. So the very first thing we need to do is get our x's together. So I like to move variables to the left. That's just my preference. You always want to leave something on either side of the equal sign. So I wouldn't want to move the 4x because then that wouldn't leave anything on the left-hand side. So if I add 4 and 8 together, that's going to give me 12x is equal to 42. You kind of get the gist of it now. Notice kind of like last step is usually always going to be some sort of division. So in this case, I'm going to divide both sides by 12. And so when I do 42 divided by 12, that's going to give me 3.5. Now let's look when there's a combination of variables and numbers on both sides of the equation. The thing that kind of gets students with these is there's no right or wrong in terms of where you start. You kind of got to come up with what's a preference for you. When things start getting long and complicated, I encourage students to take your equal sign and sort of draw a wall down the middle so you can see this is the left-hand side, this is the right-hand side. Again, your goal is to get variables on one side and numbers on the other. So you can start here by getting rid of the 7 and moving it to the right-hand side, and then you're just going to bring everything else down. So you're left with 4x on this side. You can combine 7 and 13, which is going to give me 20. Now I want to get my variables on the other side, so I'm going to move the 9x over, do minus 9x here. So it's going to give me negative 5x is equal to 20. And my last step, I'm going to divide by negative 5. And I'm going to get x is equal to negative 4. Now, I want to do this a different way just to show you it really doesn't matter where you start. So, for example, maybe you wanted to move the 4x over here. So you can minus 4x and get it over here with the 9. That's not my preference personally, but maybe that's where you wanted to start. Now, I wouldn't want to move the 5x. I want to get my numbers on the same side, so I would minus 13. So that would be negative 20 is equal to 5x. You can kind of see where this is going here. Divide by 5, and I get negative 4 is equal to x. So you can see it doesn't matter. Now, my preference is to do this, which is get variables on the left and numbers on the right. Typically, if I can come up with some kind of routine that I can use every single time, it helps me in math. So let's look at some more examples. I'm going to draw my line here, kind of separate my two sides. I'm going to move my variables to the left, so I'm going to minus 3x. That gives me 8x plus 14 is equal to negative 4. I'm going to move the 14 over by subtracting it. So I get 8x is equal to negative 18. I'm going to divide both sides by 8. Now, if you do have something that ends up being a fraction, what you can just do is simplify the fraction. So in this case, we can simplify negative 18 over 8. We can divide both sides by 2. So it's going to give me negative 9 over 4. And you can just leave it that way. Same thing here. I'm going to draw my line. Now this one's a little bit different. Notice what you got on the right-hand side. You can combine these two together. And you can combine these two together on the left-hand side. Now, when they're on the same side of the equal sign, you don't change the sign. The only time you change the sign is when something picks up and moves from one side of the equal sign to the other. So I can combine 18 and then minus 3, or 18 plus negative 3, which is going to give me 15. On this side, I can combine 16 and negative 13, which is going to give me 3x, and then plus 12. Now notice I've got my variable over here. I want to move this number to get rid of it, so I'm going to subtract 12. So 3 is equal to 3x. My last step is going to be to divide by 3 to get rid of it, and I get x is equal to 1. Let's make it a little more complicated here. So we're kind of combining all the things we've learned so far together. We're going to distribute first, so we're going to get 8x minus 24 plus 5x is equal to, we're going to distribute the 15, so we're going to get 15x and then minus 30. Notice on this side I can combine 8 and 5 together. Again, I don't change the sign because they're on the same side of the equal sign. So we get 13x minus 24 is equal to 15x minus 30. I'm going to move my variable to the left by subtracting 15x on both sides. So this is negative 2x minus 24 is equal to negative 30. I'm going to add the 24 to get rid of the number, move it to the right-hand side. So I get negative 2x is equal to negative 30 plus 24, which is negative 6. I'm going to divide by negative 2, and I get x is equal to positive 3. Let's look at another example of this. Draw my line, kind of separating my two sides here. I'm going to distribute my 3, so it's going to be 6z minus 9. I'm going to bring down this minus 3 is equal to 3z. I'm going to distribute a negative 2, so that's negative 4z, and that's going to give you a positive 2. Combine both like terms on either side, so I can combine together. I just noticed I wrote an x instead of a z. That would have been terrible. So let's fix that real quick. So this is going to be 3z. There we go. So we can combine together negative 9 and negative 3. So this is going to be 6z minus 12 is equal to, I can combine together 3z and negative 4z, which is negative 1z. I'm going to move negative 1 by adding 1z to both sides, so do the opposite. So this is going to be 7z minus 12 is equal to 2. I'm going to add 12 to both sides. So 7z is equal to 14, and then I'm going to divide by 7. So I get z is equal to 2. Again, keep in mind, you can check your answer. You can plug 2 back in every time you see a z, and as long as the left-hand side is equal to the right-hand side, you know you've done this correctly. Now, how do we deal with equations that have fractions, which of course is everybody's favorite friend in math, which is fractions? If you find a common denominator between the fractions first, you can multiply all the denominators together to get a common denominator if you need to, and then you can multiply every term that's not in parentheses by that common denominator to get rid of fractions. Now, this is typically not the way that Ed Reddy is going to teach you how to do it, but for a lot of students in the past, I have found that this is the easiest way to do it because it gets rid of the fraction piece of the equation. So let's look at an example. You want to look at all of your fractions here. So notice you have a denominator of 4, 4, and 2. So what is your least common denominator? That is a number that all of those would go into. Now you can pick, it doesn't necessarily have to be the least one. So for example, like 8 would work, or 16 would work, or 20 would work. But the lowest number that all of them would go into would be 4. So what I'm going to do is I'm going to multiply every part of my equation, regardless of whether or not it's a fraction, by 4. So if I do 5/4 times 4, again, you can use your calculator, or you can do 5 times 4 and then divided by 4 is going to be fine. Either way, 4 times 5/4 is just going to give me 5. So that's going to be 5x. So notice really those two canceled each other. 4 times 1 is going to give me 4. Now if you do 3/4 times 4, you're just going to end up with 3. So that's going to be 3x. And then if I do 1/2 times 4, that's going to give me 2. Now notice by multiplying everything by that least common denominator, the fractions are gone. Now this is something I can solve just like I've been doing. I can subtract 3x to move it over, which gives me 2x minus 4 is equal to 2. I can add 4 to both sides, so that gives me 2x is equal to 6. Divide by 2, and I get x is equal to 3. Now, anything that's not in parentheses has to get multiplied by a least common denominator if you're going to use this method. So my least common denominator between my fractions here, you could use 15, because that's a number that 3 and 5 would both go into. So I'll times this fraction by 15, I'll times this fraction by 15. Don't forget, this 2 is not in parentheses, so it's got to get multiplied by 15 as well. If you do 15 times 1/3, you're going to get 5. Notice I just brought the parentheses down. If I do 15 times 1/5, I'm going to get 3. Bring the parentheses down. And then 2 times 15 is going to give me 30. Now that looks a lot nicer to solve than the original equation. So we're going to distribute. So that's going to give me 5x minus 10. This is going to give me 3x, and then 3 times 4 is going to give me 12. I'm going to combine like terms on the right hand side, so I can combine together 12 and 30. So 12 and 30 is going to give me 42. I'm going to move the 3x over. So this is going to give me 2x minus 10 is equal to 42. I can add 10 to both sides. So 2x is equal to 52. And then my last step, I'm going to do 52 divided by 2, which is going to give me 26. Let's look at one more like this. It's a little more complicated. So our least common denominator between 7 and 6, we could use 42 because that's a number that both of them would go into. So I'm going to multiply everything by 42. Now, if I have something like this, really what I would suggest students doing is to do 42 divided by 7. So with fractions, you can always take the whole number and divide by the denominator, which gives you 6. Now 6 is what's going to end up being distributed to this numerator. So we're going to do 6 times x plus 2 here. You could use that same concept here. 42 divided by 6 gives you 7. And so we're going to do 7 times x, which is 7x. And then we're going to have to do 42 times 2, which is going to give me 84. Now this looks like something I could solve. We're going to distribute the 6, which gives me 6x plus 12. I'm going to move the 7x over and subtract it. So negative 1x plus 12 is equal to 84. I'm going to do 84 minus 12 in order to get rid of the 12. So minus 12 on both sides. So negative 1x is equal to 72. I've got to divide both sides by negative 1. And so I get x is equal to negative 72. Now, do all equations have a solution? And the answer there would be no. Sometimes you'll have an equation that will either have no solution or it'll have infinitely many solutions. You may see this written as all real numbers as well. If you subtract on both sides and you get the variable by itself and you end up with a false statement, so for example, 7 is equal to 0, this is false, and so the answer there would be no solution. However, if you end up with just a true statement, so for example, 7 is equal to 7, this would be all real numbers. So let's look at 2 examples. I'm going to start off by trying to isolate my variables. So 2x minus 2x gives me 0. And you've got 0 plus 3 is equal to 7. So does 3 equal to 7? No, it does not. So this is an example of no solution. Now with this one, I'm going to distribute the 5. So this is going to give me 5x minus 45 plus 3 is equal to 5x minus 42. Excuse me there, minus 42. So I'm going to combine like terms here. And this gives me 5x minus 42 is equal to 5x minus 42. You could stop right there. So if you end up with a true statement, this side is the exact same as this side. This is an example of all real numbers or infinitely many solutions. So again, if the left-hand side of your equation turns out to be the exact same as the right-hand side, this is all real numbers.